at questions on number 10. In number 10, if we are going to rewrite this, this is exactly like on the top of your notes from class on Tuesday. And what it said to do with each one of these, in both 9 and in 10, is it says rewrite it by taking the numerator and dividing it by that denominator. Now, in number 9, as we look at that problem, we are going to simplify that to 2 over 3x, and 3 over 3 becomes 1, and we are done. In number 10, it doesn't work out quite as nice, but you're going to leave your answer as 11n divided by 9. You're not going to change it to a mixed number. You're going to leave it improper, and 14 over 9. And you're just going to leave it in that form. You're not going to change them to mixed numbers. So when you are doing those problems, that's simply all you have to do is you look at number 10, 11, 12. Now, when I look at both number 11 and 12, you have to simplify first. So similar to how we simplified 3 over 3, when you're looking at number 11 and 12, and you look at number 12, and our first step, Braden, would be to rewrite it how?
24K, and then
divided by 6. And that line does mean division, okay? That fraction bar does mean division. And then we would continue, Courtney, with 18 over 6. And both these can be divided by 6, so you want to put the simplified answer, right? By taking 24 and dividing it by 6 as you look at those. As I'm looking at number 18, your homework quiz today will have a distributive property, and then it'll have adding like terms. So when we are looking at this in the original problem in 18, how many terms do you have in the original problem? How many terms in the original? How many terms in the original? Both. 2. So if I look at the original problem, there are 2 terms, okay? The reason I know there are 2 terms is terms are separated by addition and subtraction. If you did not go over your vocabulary, that vocabulary that was in the lesson from D1, it's going to keep coming up, and I will ask those questions on the quiz. So when we are looking at this, we have 2 terms that are separated by addition and subtraction. We are going to be adding our like ones. So 23b and 19b are similar, are like. We are going to take the 23 and we are subtracting 19. And we keep our variable b. So 23 minus 19, if I'm subtracting those, Carmen, I'm going to end up with, if I take 23 minus 16 or 19, 4. So we're going to have 4b. If I look at this answer and I say, how many terms in my solution? Wyatt, what am I looking at? How many terms in my solution? You have your homework out to this page? What would I have if I said, how many terms in the solution? Because that's what I'm going to ask on the homework quiz today. I'm going to say, how many terms? How many terms from yesterday when we talked about in that answer that I just put up there? I need you to focus, right? What did you get? 2. In the original problem, 2. How about in the answer? I have 4b. How many terms in this answer? What did we just say terms were separated by, Dave?
By addition and division. Not division.
Addition
subtraction.
and subtraction. So is there any addition or subtraction, Peter, as we are looking at 4b?
Yes.
In 4b, is there addition or no? There's no addition, no subtraction, right? So if I'm looking at that, what do I know, Grace, how many terms there are in this answer?
9.
How many?
1.
Just 1 term in this solution, okay? There's 1 term in the solution. If I looked at the original problem, there were 2 terms here. On your quiz today, I might ask you how many terms in this part, and I might ask you in this part. Terms are separated by addition and subtraction. If you don't have that in your notes from the first day on D1, go back and turn to those notes. You can have that open right now, the D1 notes, where we have the vocabulary word terms, and put terms are separated. Terms are, some of you might have even written it down already, maybe Violet.
5. Addition and
By addition and
subtraction.
Some of you probably even had that down in your notes, but you didn't look at your notes after class, okay? So, the next thing I'm going to ask you in the quiz today is I'm going to say, when you look at this answer, what is my coefficient? So another vocabulary word. The coefficient of the variable. So if I'm looking at the coefficient of the variable, Layla, what am I looking at in my answer? 4 would be my answer. So if I said, what's the coefficient? So I say simplify, and then right behind it on the blank, I say, tell me the coefficient. The coefficient of that would be 4. As I look at problem number 24, in the original problem, how many terms do we have in this problem? Raise your hand, please. The number of terms in the original. All right, I see your hand, but I need to move it around a little. Sophie, what do you think? How many terms? 3. Okay, I have a subtraction, I have an addition, and I have another subtraction. So they separate the terms. So this would be my first term. My next term would be -7. My next term would be 4, and my next term would be -8. So I don't have 3 terms. I have 3 addition and subtraction. I have how many terms? 4 terms. Okay. We now want to add our like terms, right? So we might even group them together. 6a plus, Chloe, what is in front of this a? And we got to be really careful because it was a minus. So we might want to change that subtraction either to plus a -1, or we might want to put it as plus a -1a. That helps us with, for looking at the coefficients. I then have -7 and +4. And again, some of you make more mistakes when you have subtraction, so changing always subtraction to adding the opposite might be helpful. Okay? So I am adding my like terms here. Connor, what'd you get when we add our like terms? 6a minus 1a. What'd you get? 5a. Right, if I'm adding -7 plus 4, I'm going to have -3. So if I now say this is my simplified answer on our homework quiz today, and then I say, how many terms do we have? In this answer, we have how many terms, Lizzie? 2. And if I say, what is the coefficient of a, Ava, what am I looking at? 5. Okay? So that's kind of what your homework quiz looks like. Keep that homework out. I was just checking if you had it done. So I have a few of you that finished it and quite a few of you that didn't. Make sure you check these answers. Okay. Make sure if you haven't checked the answers in the back that you are checking those with the solutions to make sure that they're making sense. Okay? So today we're going to do some work with algebra tiles and modeling. So if you turn in your notes, sometimes our equations can take many steps to find a solution. One way to make this process easier is to model it with algebra tiles. As we look at it, the longer ones are going to be your x variable, so that's going to be our unknown when we look at it. We are going to have if we are looking at ours are green, not yellow, but that's going to be the positive. And if you turn it on the back, you can actually see where they have a minus on it. That's your negative one. So when we're using positive and negative ones. Same thing, the green. So if you are the yellow on here, those are the positive for the small ones, and these are the negative. So these stand for your ones, okay? Both of them have 2 sides as you look at those, okay? So here's how we could model this problem. So right below this in your notes, I don't want you to model this right now, but I want you to take a look at it. This would have been, in our case, ours were green, but this would be, if we are looking at it, right, 2x plus, just write it right below the problem, 4, plus then I have how many more x tiles? 3. And that was equal to on this side, 9. So it says we can use algebra tiles to model this. So this is the model for right here, right? We want to regroup when we look at doing our problems, and I forgot to put an X by here, hopefully you didn't. Okay?
I didn't.
So, we now want to regroup them. So when we regroup them, how many X tiles do you now have? 5X. This is the adding of our like terms. So you're writing this right in your notes. Okay? We are then putting our plus 4, and it still was equal to 9. Now, what they are going to do is, at this point, it says we will take 4 away from each side. Why are we taking 4 away? Because we're trying to always, our goal is to get the X by itself. So I would actually take and remove off 4 of these, right? If I remove 4 from this side, I need to remove 4 from this side, which means we are now left with 5, and we still had 5X. So if we are solving this, and some of you are going, oh, this doesn't make sense to me, I know I can just do the math and solve it. That's great. But since we have 5, we would have divided this out and said, okay, so since there's 5 here and 5 here, each one of these X tiles has to be equal to 1, okay? So this is just to kind of build that conceptual understanding, because we get into pretty hard equations like the front cover of your worksheet or of your workbook in your notes quite soon. So I want you right now, we are going to use your algebra tiles, and you are going to model this first problem right here. So if I do that, I'm going to have your green X, and I don't care which way you turn it, if you have it this way or if you have it the long way. Plus I need to have 3 ones. Then I need how many of rectangles? Do this with your partner. Do it on your desk. Don't stack any of them. Leave them down and model this. So, start with doing this problem. Start with the X. Then put the 3. Then put the 2X. Then put, it should be equal to 9. So now you have to have 9 ones. Okay? Now, some of these are really close with the number of ones, and if you don't have 9 of them, check with me because I can try and see. So
I don't have 9.
turn over the little ones, all there are little ones, and you have to have equal over here. If I was looking at this, I need to have 9 of them. Okay? Why do I have to have 9? Because this was equal to 9 in this equation. Okay? So, turn them to the yellow side so that you can see those. So now if I'm looking at this, I would regroup these and I would put all of my X's together, right? Put all those X's together. And I really have 3 plus X now. If I'm trying to find out what X is equal to, how many should I remove from each side as I am looking at them? Remove 3. So we're going to take 3 away from this side. Put it back in your, like just on your desk if you want. We want to take the 3 away from this side. I'm going to set mine over here to just the side, okay, that I'm taking away. And so now I have these matched up, and if you match them up, as you look at that, I have 2 for each one of these X's, which means my value of X needs to be 2. I want you to model this one with your groups and leave this on your desk so that I can see you have 4 X's plus 1 plus 2X equals 7. Okay? So move the tiles between you and your partner to get that one set up. Second problem in the middle. You're doing this one. Sorry, you're doing this one. Got it. Then you gotta have equal 7. Okay, so I want to see your groups. When your group has it, put your hand up so I can. One from both sides, right? We remove one on both sides. What was each x equal to? Each x should be equal to 1. So please put x equals 1. If you have not modeled this last one, I would like you to do that next. Do 3x. Okay? So we're going to have 3 x's when we start out. Plus another x, right? Plus 2. So I should be able to see your model. And it had to equal 10. I'm just going to take the big blue ones. We're not using those at all. This stands for an x. We start with how many x's in this problem? 3.
Yeah.
And you have 1. So you have 3x, then you have another x. Then you have how many x? 2. Okay, you're going to do it all together. I want you to do one together. Okay? So, as we are looking, this stands for, if I was looking at this problem, this is this problem right here that I have modeled. I have 3x, I have a plus x, I have plus 2 equals 10. I can tell that right away. I'd like you to write right below this 3x plus x, let's write 4x. If I have 4x and now I remove these 2, and I remove 2 over here, what are we left with? 4x equals 8. So if I have 4 of the x's equaling 8, each x must be equal to 2. Yes. So, we are not going to, if you take a look at the bottom one, this stands for how much? What is this looking like? This looks like what? We have a large one and a smaller one. This looks like x plus 1. How many of them do we have on this side? Right up here, we have 3 of them. So how do you model using kind of distributive property? You put the x plus 1, that's here, and then we're taking it times 3, because we have 3 of them. Okay, so we put 1x plus 1, we have another x plus 1 and another one. That was all equal to 9. We then want to group our like terms. So we have 3 x's. Please write this in your notes, plus the 3. Still equal to 9. We remove 3 from both sides, and we are left with 3x equals 6. My solution is each one of the x's is equal to 2, because there's 2 across from each x. So when you set these up, again, don't stack them, just leave them laying down on your desk so when you're moving them around, so that when you look at this, each x is equal to 2 for our solution, okay? So, it says you can use algebra tiles with negative exponents also. So at the top of the next page, they show this. They show, here's our original problem, positive 6, and this is where you would have turned over those x tiles and made them the negative ones, negative x and negative x. We still have our positive 8. The question is, it says to add 2 positive x bars to both sides. So I want you to model this right now with your algebra tiles. Put 6 ones, 2 negatives, 8 ones. Do this as a group so you have this whole thing on your desk between the 2 of you. Okay? So 6 ones, 2 negatives. Okay? So do it going across. Do yours going across just like mine is so I can see 6 plus negative 2x equals the 8. Do it going across on your desk. Don't do it. Some of you are doing yours vertically. Don't. Do it exactly like this. Okay? It next says, next to your 2 negative x, we're going to add 2 positive x bars. So put a positive x on this side and another positive x. And you must do the same thing to the other side. So put 2 positives over on this side with the 8. Okay? If we look at this problem, right? If we look at this problem, we now have, if I have a positive and negative x and a positive and negative x, that's 0. There's nothing there anymore, right? So remove those positive, negative combinations, right? Remove the plus negative x plus negative x. What do you have left? Over on this side, you still have 8 and 2 x's, and over here you have 6 ones. If I want to take away 6, right, because we can't take away 8 from this side, doesn't that make sense? We cannot take away 8. There's not 8 here. So I am going to take away 6. As you take away 6, there's going to be nothing here, right? That's 0. Equals, what do we have left on this side? Let's write that out, please. We have 2x plus 2. Okay? Take your algebra, the little ones, and flip it to the red side. Make sure you have this model. Make sure you have a 0. Then over on this side, you have 2 positives, and you have 2 positive ones. That's all you should have. Okay? In order to make the positives a 0, we have to add, it says 2 negatives to both sides to cancel. So, if we think of this as being our equal, you now have negative 2. When I put these negatives, what happened to a negative and a positive if we add those together? That's going to be -0, right? This is 0. So we have 2 x's is equal to -2, which means 1x is going to equal what? X. 1x is equal to what tile? 1x equals how many negatives? 1 negative. X equals -1. Make sure you have that down. Now, for some of you, when you're doing this, you're kind of going, oh, this just doesn't make any sense. I'm not getting this with the algebra. I'm not going to require you to do those or do your homework or use that. But the key thing is that with this unit is this kind of builds the conceptual understanding. So I would like you to model this first one. How many x plus 4s do I need you to put down? How many x plus 4s? 2 of them. So start with moving. And if you want to put them right on your workbook, so you have x plus 4, right? And then put another x plus 4. And then it has to be equal to 10. So do the model with your and then we have the 10 on this side. Now, if I am doing this, when I combine my like terms, right below this problem, I want you to go down below. How many x's did you have up above? How many x's are we looking at? We are looking at 2 x's. So right below this, please write down here 2x. How many 1 tiles do you have? 8 plus 8. Well, we're going to have you hold up. You can just write it down instead of saying. And then we have that equaling the 10, right? What do I need to remove from both sides? What's the most ones that I can remove from both sides? I can remove the smaller number, which means I can remove 8 from both sides. If I remove these 8 and I take them away, and we are removing all of these 8, and we take them off our desk, and I remove 8 from the other side, what am I left with? I should be left with 2. So we're going to have 2x. If we are looking at that, writing 2x equals 2, which means if I only have 2 left on this side, and I have 2 x's, what is my x equal to? 1. We're not going to model these other 2 today because I want to take that homework quiz and I want to talk about your assignment. Okay? So, if you would please take a look with the algebra tiles, put them all back in the bag. Check on the floor by you. I will come up to pick up your bags. You do want to do the joke. I don't know if your math teacher had you do it last year or not. I want it done. Then I know if you got it right. So when I take a look at the first question I, okay? Yep, I'm coming together. As I take a look at the first question I, my operation is addition. What is the inverse operation that you must show? Subtraction. So right below this, and you should be able to do the work right on here, you're going to minus 12 on both sides of the equal sign. Okay? If I do that, what are you going to be left with? N equals 4 minus 12. Or 4 plus a negative 12 gives us negative 8. So up above, I'm going to find negative 8. And any place where I have a negative 8, I'm going to put the letter I. Please go across to this next one where it's letter S. Okay? If I'm looking at letter S, my operation that was happening was multiplication. What is the inverse of multiplying both sides by negative 15? If I'm looking at that, I should have, Chloe, what? Inverse of multiplying by 15, negative 15. Divide. So I'm going to divide both sides by negative 15. If you need to use your calculator, you can. R is equal to, well, when we take negative 75 divided by negative 15, we should have, we'll check. Then we're going to go down and look at the letter K. F5. Yes, right. Oh, Mrs. Thompson, I don't want to show this division by negative 15. Then you just had a 0 on your worksheet. I will not give you any credit for it. So, when you are doing this, I want to see the inverse operation. I know, but I get this. This is so easy. I don't need to show this. That's okay. Just, you want to get credit for the assignment? This is a hoop you have to jump through, right? You got to do this. So this letter K says B is divided by 3. What's the inverse of divided by 3?
Multiply.
Multiply. I need to see, don't throw it anymore, Brady. We need to multiply. Same with you, both. Don't throw. If we are looking at this, I appreciate it. What happens to 3 over 3 if I'm looking at that? 3 over 3 becomes 1. And we're left with B equals, Daniel, what you get as you're writing this down? Negative 33. Up above, every place where I see negative 33, I'm going to fill in the letter K. Questions as you are looking at these. Please take a look. There's one that really seems to give people problems, and that is, remember in front of A, what number is this in front of X if there's no number? 1. So my coefficient is negative 1. Here's how I want you to rewrite letter P. I want you to put letter P and put the negative in the denominator and make this a positive up here. Because we're trying to solve for positive A, and you can always, if there's a number, like especially a 1, you can make that negative go to the denominator, okay? You are solving this, make sure you show the inverse operation. If you don't feel like there's enough room on this worksheet to do it, then do it on a separate sheet of paper.